In this session, we're going to be discussing HTTP cookies and, in particular, all of the important attributes and behaviors of them and of the browsers that handle them as it pertains to cross-app security. So we are in cross-app security session number 2. So what are HTTP cookies? This is my own definition that I've formulated: a browser-managed data storage and transmission mechanism where key value pairs are associated with web applications based on defined scope. And the reason I formulated this is, one, I think it's a nice, concise definition, and I think it cuts to the core of what cookies really are, which are really just a way to store data and to create a set of rules for when browsers and servers exchange that data as well. There's not really anything more beyond that. It's very easy to, I think, implicitly tie our understanding of cookies to session management in web applications, but cookies don't have to be used, and in many cases they aren't used for session management. They're used to implement stateful systems across HTTP, but session management systems can exist without HTTP cookies. HTTP cookies are more of a mechanism that exists, again, to transmit and to store data, and it's best to think of them in that way, in my opinion. In the most recent RFC 6265 HTTP state management mechanism, it states that although cookies have many historical infelicities that degrade their security and privacy, the cookie and set cookie header fields are widely used on the internet. So I mentioned this in the previous session, and I'll reiterate it again here. A lot of technology on the web and a lot of security mechanisms on the web are really built around technologies that were developed without the foresight for the problems that we might encounter when trying to build a secure and functional ecosystem. And HTTP cookies are one of those. They're so pervasive, we can't replace them with something better. We are stuck with them. And as a result, there are a large number of security mechanisms that are layered on top of them that have been implemented over time and are always changing. So what we're looking at in this session is the current state of HTTP cookies and their behavior. I'm not going to evaluate the historical context, how it developed, the time at which different features were implemented. We're going to look at how they exist today and what the best practices and what the concerns are around that. As far as key concepts, I already mentioned that cookies are distinct from sessions. Oftentimes, cookies are used as a mechanism to implement sessions. And, really that's, I'm going to jump to the last bullet point. Really, that made a lot of sense on the early web because there wasn't a good stateful mechanism to keep track of state between independent requests. Like HTTP as a protocol is stateless. You send one request, you get a response, that's it. You send another request, you get a response. How do you correlate those two requests as being associated with the same user or same session? There wasn't, prior to cookies, a robust and universal way to do this. So, or maybe they were, but perhaps they were a little bit hacky. So cookies were introduced as a mechanism to make this stateful. If you use cookies that store some type of identifier and you send that identifier on multiple requests, the server that you're interacting with has a way to tie together all of those HTTP requests and recognize them as coming from essentially the same authority, belonging to the same session when implementing a session management mechanism. So cookies are often thought of in that way as being defined by servers and being set by servers as a way to manage sessions. But you can also create and set cookies client side. And this is, of course, very important from a security and attacking point of view. One piece of terminology that you'll hear used, which I think isn't perfectly in line with the original definition, but you'll hear the term ambient authority or implicit authority when talking about cookies. And this applies in situations where a cookie that is tying together multiple otherwise distinct HTTP requests in order to form some type of session is usually conveying some level of, it's used to authorize requests, right? It's tying a session to an authenticated identity, and it works in the browser implicitly. So you as the user are not making a conscious decision, hey, when I send this request, I would like to include these credentials. No, the credentials, so far as they're contained or identified by cookies are sent automatically by the browser, and this leads to many possible issues. The scope of cookies is the set of rules that determines what URLs cookies are sent to. That might be a little bit overly narrow of a definition of scope, but I tend to like to separate scope, which is all of the rules that determine where cookies could be sent to, from the security mechanisms that restrict the sending of those cookies in certain situations. And if none of that makes sense, I promise it will by the end of the session, because we're going to talk about both the scoping of cookies as well as the security mechanisms that govern when they are and are not sent in certain situations. And that concludes this slide. So common cookie use cases. I'm sure everyone is familiar with authenticated session management within applications that traditionally have used cookies. A lot of web frameworks are built around this, so they'll have session management components that just by default use cookies. It's not universal. You'll see other mechanisms used as well in addition to cookies, but cookies, of course, are very traditional. They're very common. Even applications that aren't using cookies as a mechanism to manage primary authenticated sessions probably are using cookies for something else. So you pretty much on any given web application are going to see some cookies. They can also be used, because they're used to represent sessions and build state into HTTP. They're not just used for authenticated sessions. They can also track unauthenticated sessions. So for example, if you're going to an e-commerce site and you create a cart, you're adding items to that, you haven't logged in, you haven't bestowed upon any cookies some level of privilege by tying it to an authenticated identity, but the application nevertheless is able to track between visits what you've put in your cart. It has saved in your browser a cookie that can be used to identify you between browsing sessions of that application. And so that is effectively an unauthenticated session that is managed through the use of cookies as a mechanism to manage that session. Similarly, personalization and preferences. You'll often see cookies used to keep different preferences and settings about your usage of an application. Security mechanisms also make use of cookies in some cases. We're going to have a session about cross-site request forgery in the future. If you're curious about the specific mechanism that is typically employed using cookies to prevent CSRF style attacks, it's called the double submit pattern, where cookies as a mechanism, just because of how they behave, can be used to mitigate some types of CSRF attacks. Load balancing, there are use cases for cookies, and of course trackers and analytics historically have had probably, I would say, even make up the majority of cookies that are deployed across modern web applications. Like if I had to take an educated guess, I would say most cookies that have been created and are in use are probably for the purpose of trackers and analytics. And I think that you'd recognize this just browsing popular websites, because usually there's only a small number of cookies that apply to your active authenticated session if they're using cookies for a session management purpose. But then there are a large number of other cookies that relate to other components, and we'll talk a little bit about some of those, as well as some of the modern restrictions that are being deployed to mitigate the impact of tracking that results from what are known as third-party cookies. So I mentioned that, of course, you can manage cookies from the client side. Traditionally, cookies are set by servers, and this is what it looks like. On the left-hand side, this is how cookies are. On the left-hand side, this is how cookies are set by a server. So this would be an HTTP response. You can see the HTTP status code at the top, and you can see the HTTP header set-cookie, and then we're defining a cookie as a key value pair, the name being theme and the value being dark, and the content type is irrelevant for the purpose of cookies here. On the right-hand side, we see the subsequent request, right? So once a cookie is set in your browser, there are going to be certain rules that the browser applies based on how that cookie was set, what the attributes are, that determines when it's going to send it. But in general, it's going to send them back to the application that set them. And so here we see a GET request to some dashboard page, and we're sending the cookie back with the same name and the same value. And oftentimes in practice, as I mentioned, a lot of applications, you'll see a lot of cookies. And so in this example here, this is maybe a more common scenario that you'll see when you first browse to an application and it's setting cookies, you just see this mess of cookies with varying purposes and varying attributes. And from a security testing point of view, some of these for sure are going to be important. Some of them are going to be less important. As you develop your testing intuition and knowledge and skills, you come to recognize certain patterns, certain cookie names, things that correspond to load balancers or cloud proxies. It's a lot easier with more experience to filter out the noise, but in many cases, when you're first approaching an application and it sets a bunch of cookies, it's worth looking into what those cookies are, what they do. Oftentimes, if you search them, you can find out their purpose. These days, too, with language models, sometimes language models can be useful tools for identifying what the purpose is of a cookie and potentially how it works. If you're having trouble Googling for it, for example, in particular, cookies that include special characters may be hard to search for on certain search engines. And of course, we can also interact with cookies on the client side in certain situations. So on the left-hand side, this shows how we might get a cookie that has been stored in our browser through one or more means. In this case, there's a couple cookies that are set, so we get 2 cookies that are being returned. The comment there on the left-hand side is just showing what that log would look like in the console. And on the right-hand side, we are setting a cookie. Document.cookie, source theme equals dark. Maybe a silly example in this case because I guess if we look at the first example, we assume that cookie's already been set, but that's a simple way to set a cookie using client-side code. So cookies can be configured in many different ways, and the ways in which we do this are with cookie attributes, or what you'll also see referred to as flags. And we're going to go through the set of those. We're not going to talk about all of them immediately. HTTP only is set by the server, and it can actually prevent JavaScript access. So accessing document cookie in the JavaScript, if a cookie has been set by the server and it's been set with HTTP only, you can't do this. The secure flag is also a very simple flag. If you set a cookie with secure over an HTTPS as opposed to an unencrypted HTTP connection, so these are for connections that are using transport layer security, TLS, and when you set the secure flag, it tells the browser, hey, under no circumstances should you send the value of this cookie over an unencrypted connection. We set it in an encrypted connection. We've specified the secure flag. Do not expose this over an insecure network. Same site is an attribute that restricts when cookies are sent depending on the context of the request. We'll talk about that later. Domain sets the scope according to a chosen domain, and the path attribute sets the scope according to a chosen path. And we'll dive into those in a moment. First, this is all we're going to say really on HTTP only and secure because they're very, very simple. Just showing a really quick example of the HTTP only flag in action. So in the code on the right-hand side, it's just creating a simple function to search for cookie values. And we're searching for a presumed cookie named HTTP only protected cookie that has the HTTP only flag set, and we can't get it in the JavaScript. This flag has often been used and recommended as a mitigation to cross-site scripting and related attacks that might be able to retrieve session cookies. These days, it's not really seen as that much of a practical protection mechanism because once you have cross-site scripting on a target, you can really still conduct every action that the user could do. Oftentimes, there's limited value to actually just being able to obtain the full session. As far as impact, the impact is about the same. So HTTP only has kind of been relegated to the status as a security mechanism that, like, it's good when you can do it, but it, in practice, doesn't seem to make a huge difference. The other thing that we'll see, or that we see in a lot of modern applications, which is somewhat related, we're not going to go over it in this presentation, but we see increasing use of browser local storage mechanisms, and those mechanisms can't be protected from JavaScript access. So it seems like the industry broadly and developers with modern web paradigms have just kind of accepted that it's okay to store sensitive information like sessions in locations where JavaScript can access it. Because if attackers can run JavaScript in the context of your application, in the context of your authenticated user session, it's pretty much game over anyways. The secure flag, on the other hand, should always be set. We're not quite at the point where browsers entirely default to encrypted communications only. So it still does play a role. There are still possibilities where an attacker could coerce a browser to make an unencrypted request. And if the cookie is not protected, it could be intercepted and used by an attacker. So still a solid recommendation. Both of these, as you'll see in the bottom left, are findings that we use here at Digital Boundary Group: session cookie without HTTP only flag set and session cookie without secure flag set. You'll note that we're using the qualifier session there when reporting them. There may be other cases when you want to report cookies that are missing those, but usually it pertains to session cookies, things like trackers, analytics, cookies. Those we're often less concerned about. There might be some exceptions, but usually we're not considering those to be as sensitive as cookies that are used as part of a session management system. As a quick aside, because it is important for the scope of cookies, it's always good to be mindful of canonical domains and just how applications behave when you access them on like a root domain or using www. So example question, should ex.com be equivalent to www.ex.com? Fundamentally, these are actually different origins, and there are implications for the handling of cookies. So the subdomain www originally emerged, I said there wasn't going to be much history, but here's a little bit, to denote a web service as distinct from other services that might be hosted by an Apex domain. So other services that you might have would be like non-web services. I don't know, FTP, for example. You've probably seen a subdomain ftp.site.com as being very commonly implemented to tell you that that host name resolves to a system that has an FTP service that is exposed. So what the common practice is, and the recommended practice, what I'm calling the best practice, is if you have a site that you want to host from, like a root domain, essentially it's your main application on your main domain, it's best to choose and enforce the use of www as a subdomain, as the canonical subdomain in particular, for all app traffic. And any attempts to access like the root domain as opposed to using www should be redirected to the www variant. And we do actually at DBG have a finding for this that is worth reporting in some situations, and that is canonical World Wide Web subdomain policy not implemented. Domain and path attributes, these are the fundamental attributes that determine the scope of your cookie. So what URLs can this cookie apply to and be sent to? So these are the rules that browsers use to determine the scope of URLs that the cookie should be sent to. Because remember, for a lot of these attributes, the browser is what is really applying the security mechanisms. And what's interesting about these attributes is, depending on how you set them, they can actually broaden or restrict cookie scope compared to if you didn't set these attributes at all. And so one of the big implications for this is that applications share security context with subdomains and subpaths. So there's actually a finding down at the very bottom of this page, shared application site or origin, that we will sometimes report. And these are situations where there are multiple applications served from the same site or the same origin. And this poses a risk, especially in relation to cookies, because they could very well share cookies. And so the security posture of each application is dependent upon each other. And one common attack that's used to abuse this is known as cookie tossing. This is a situation where, let's say, you want to target some high-value application that is served on a root domain, importantsite.com, and they have so many subdomains where that's how they've decided to separate their applications by subdomain. You only need a vulnerability on one of those subdomains that it allows you to introduce a cookie, and you can set a cookie and specify the domain attribute pointing to that root domain, and now that cookie will also be sent to that root. So you can use these attributes, domain and path, to set cookies to apply to a scope that is greater than where that cookie is actually being potentially set from. There are some restrictions to the domain value. It must, of course, be a suffix of the setting host. So you can't specify a domain for a completely different site. Obviously, browsers will reject that. You also cannot set it against an effective top-level domain such as .com. I think that's probably obvious, right? Those two things, if they were permitted, would fundamentally break the security of the web. There's also another finding that I didn't mention before, where cookies are set and they're not sufficiently restricted. So session cookie scoped to parent, domain, or path. That would be a situation where there's a application served on a subdomain, and the cookie is overly scoped and therefore is by default shared to applications when the user browses to it that probably should not have access to those. Even if they're owned by the same organization, it really is best to isolate the sharing of cookies across applications because the security posture varies. And when you have those interconnections, those relationships between applications, it just increases the potential impact when a vulnerability is identified on one of those related applications. So I put together this table of just some simple examples, and I call this traditional cookie scope because we're not considering some of the other mechanisms that are more modern that restrict when and under what circumstances browsers send cookies. These are just showcasing some basic examples. So looking at the first line, we have a cookie set by www.ex.com, and I'm going to say that it's not set with any attributes. And so the path and domain in this case have implicit values. When you don't specify them, they take on defaults. The default domain is going to be the essentially the full host name of the system that sets it. The path is going to be the last complete path segment. And hopefully that will make sense when we get to the bottom example. So looking at where the cookies may be sent to, and of course this is a non-exhaustive list. I could come up with so many examples for both of these categories. It will be sent back to the exact same URL. Because secure hasn't been specified, it can be sent to an unencrypted HTTP URL. It can also be sent to an application served on a different port. So this is, in both of these cases, right, a different protocol, like HTTPS versus HTTP, different port. Both of those cases are different origins, but cookies don't work by following same origin policy. They're a lot more permissive. So they would go to both of these. Any path that you specify here, because the path has been set to the root, they're going to be sent to. What you're not going to send this cookie to is going to be like a different domain. It's not going to be sent to different subdomains. And in this case, it won't actually be sent to the root domain because without specifying domain, it gets scoped to www as a subdomain. Looking at the second example, again, this one's simplified by removing that www. Again, we don't have any attributes specified, and so the scope of this cookie is a little bit different. In this case, it will be sent to the root over a secure connection, over an insecure connection. It will be sent to both of these subdomains, www and API. It won't be sent to completely different domains. In the third row, we have the same original URL that's used, and now we're specifying the domain as the root domain or the apex domain, ex.com. And the big difference here is now that cookie will be sent there. So you can see under cookie may be sent to, we've now included ex.com that cookie is going to be sent to by the browser. In the final example, we just look at the behavior of the path. So we have what I'm calling a complete path segment, the /app/, and then we have profile. The way that path works, it will strip back up to the final / after app, and therefore any path that is downstream of that app will be sent to. I clearly made a mistake when building this because in the examples the two are the same, but just pretend that the second one is app/dashboard or something, right? A different final path segment is at play there. And in the examples, of course, the domain restrictions still apply because the domain not being set defaults to www. And you can also see that a different kind of root path segment, app2, the cookie will not be sent there. Of course, all of the attributes, you can inspect how they're set by the JavaScript and by HTTP responses. But if you want to get a ground truth of how the browser is recognizing all of those cookies and what their attributes are, just go to the browser DevTools in any browser. In this example, I'm pretty sure this is Firefox, and these are obviously non-sensitive cookies. The value of them is all 1. This is just a site that I use to create some nice-looking code images. And yeah, you can easily inspect all of the attributes there. Super easy. So as far as cookie identity and uniqueness, so in addition to the scope, it's also worth keeping in mind that the scope of a cookie in part plays a role in creating its identity. And that's what we're going to talk about now. This line here, of course, is a set cookie HTTP header that you would see in an HTTP response. We have the name of it, some cookie. We have the value, some value. We are setting the domain to www.somesite.com, which we assume that we can set that in this case. And the path is just the root path. I guess I could have just had this display come up to showcase all of those. But the important point here is that cookies are uniquely identified by their name, the domain that is set against them, and their path. We've already talked about the default domain and the default path, so I won't talk about that again. Obviously, one thing you can have is conflicting cookies that are both have exactly the same identity. Cookies must be unique, so you can overwrite cookies. But because we require a unique name, domain, and path, cookies aren't solely unique just by their name. And as a result, you can have situations like this. So on the left-hand side, we see an HTTP response that is setting 2 cookies. And both of those cookies are named session, and they have different values. It's not a very interesting example. But what differs here is that the path for each of them is unique. And as a result, the browser stores both of those. I'm actually not sure. I think you can set both of these in one response. Yeah, because they are unique. So that should actually be respected by the browser. But in subsequent requests, as long as the scope of both of those cookies apply, the browser can send multiple cookies with the same name. And obviously, that can have implications depending on how your application is implemented. If you're just assuming that there's one cookie of a certain name, that obviously matters. Of course, there is an ordering by browsers. That could vary based on your browser. It could vary over time. That's actually, just as a broader point, worth pointing out that a lot of the things discussed in this session are very much point in time. A lot of these things change commonly. You've got specifications that change. You've got the browsers that change. But as of when this blog post was written that I've cited down at the bottom, the ordering by browsers was path length from long to short, and then last updated from least recent to most. Why is that important? Well, you may have situations where an application is expecting one cookie, and it will look for, the first one or the last one or something like that. And this is called cookie shadowing, by the way. So when and where are cookies sent by the web browser, of course? So cookies mostly, as we've seen, follow same site scope. Which means that they are shared in many cases cross-origin. Cookie identity and scope is determined by name, domain, and path. The secure attribute ensures cookies are sent over HTTPS only. The same site attribute, which we haven't really talked about yet, restricts scope depending on the source and destination and how the request was initiated. And there might also be browser-specific behaviors that also impact what are known as third-party cookies, which are effectively cross-site. But third-party and cross-site are not perfectly aligned. But yeah, there are certain browser features that restrict third-party cookies in certain situations. So Firefox, for example, implements enhanced tracking protection that includes total cookie protection. Some of these features are also configurable if you go into your browser settings and you're toggling the button between the different levels of strictness in terms of security and privacy. Safari has ITP, And Chrome has chips, but that also now has come to other browsers. So we're going to talk about that in a moment, including the partitioned attributes. First, a little bit of background on tracking cookies, what is meant by that, and how tracking works or has traditionally worked with cookies. I say traditionally because modern browser mechanisms do make this a little bit more challenging and kind of change the rules of third-party tracking situations. But consider the scenario: you're on some top-level site, news.com. You're reading your favorite news.com website, and that page implements a tracker, which it comes in the form of some JavaScript. So that JavaScript, of course, is sourced from a third party, tracker.example. So when your browser makes a request to retrieve that JavaScript file, that request is actually going to a completely different site in origin. The request is going to tracker.example. And so therefore, in that response by the tracker server, they can set cookies for their domain. And so you can see that in the bottom, they're setting that cookie. And your browser now stores a cookie that is known as a third-party cookie. The cookie was set not by news.com, but by a resource, by a server that was called by a resource that news.com has embedded. And traditionally, one of the ways in which this can work to track you across different websites is if you now go to a different website and it's embedding a similar resource that has the same cookie scope applied, your browser still has that cookie, and when it makes a request to that resource, it sends that cookie along and says, like, I already have this and the scope applies, so here's the cookie. And that service is now able to correlate your activity between different applications as long as they're coordinated on the trackers that they're using. You can actually view the current status of browser capabilities and protection mechanisms at cookiestatus.com, but we won't be doing a really deep dive into these mechanisms and the landscape of tracker and anti-tracker approaches. But I will mention one mechanism because it is newly implemented across all browsers, I think, as of December 2025. This is called chips. Cookies having independent partitioned state. And so this introduces a new attribute that I haven't mentioned yet that you can apply to cookies in HTTP responses. And so cookies with the partitioned attribute will live in isolated cookie jars that are scoped per top level site context. So the purpose of that is to allow limited third-party state without cross-site tracking. So if I go back to this example here, so when you retrieve this cookie that is set by this tracker, now this cookie is enriched with additional information, is a way to think of it. So now it's not just the scope of what set it and what it should be sent to, but included in the scope of that cookie is, hey, this cookie was set when you were visiting news.com, and therefore it only applies again when you're visiting news.com. It belongs to the news.com partition. So you go to a different site and you have that same tracker, but you're on a different top-level site. You're on fakenews.com because you want to get something a little bit more interesting, and that cookie is not going to be set because there's no the cookie. It looks for the relevant top-level partition, doesn't exist. So that's roughly how that mechanism works. I have some text for an example here, but I already walked through one, so we will skip it. And here at DBG, we do have a new finding for this third-party cookie without partitioned state, but we're not kind of robustly assessing this right now. It's too new of a mechanism, and we have to come up with a solid rule set for when it should be applied in order to best protect applications and their users. Cookie prefixes are very much underutilized and I think often confused. And when you read a lot of resources on HTTP cookies and how to protect them, you see a lot of focus on the classic attributes, HTTP only, secure, same site, but a lot of cookie readings and tutorials out there just completely ignore prefixes, and they're not really used that much in practice, but they do actually have a significant benefit. And the benefit in particular is to guarantee the integrity of cookies in order to protect against certain types of attacks. So just to give you one example, we talked about cookie tossing already. Cookie tossing is a situation where you're able to, let's say as an attacker, write a cookie on a subdomain where you want to actually target that domain. You want to be able to have that cookie apply at the top level domain. And so the way that you do that is you manipulate the domain value, and you say you point it at the top level domain. With cookie prefixes, that's one of the things that these can protect, because the browser applies certain rules to these cookies, and it will therefore prevent creating such a cookie as long as it has a prefix, right? So if you're a server receiving cookies with a prefix, you know the conditions under which they were created and what the restrictions are. Otherwise, the browser wouldn't send them. I hope that's clear. So let me explain them specifically. So with the secure, and by the way, it might not be clear, there are 2 underscores followed by the keyword and then a little dash at the end. And then what would follow is your cookie name. So any cookie with this prefix must be set with the secure attribute and from a URI considered secure by the user agent. But the more strict one is host. So in addition to the secure requirements, the cookie is sent only to the host that set the cookie. And when you're setting a host cookie, you can't include a domain attribute. Remember, that's the key capability when you're conducting a cookie tossing attack, trying to overly scope a cookie when you're setting it from a subdomain. You set the domain attribute. Well, the browser won't let you set a cookie while also specifying a domain attribute. It says you can't custom scope to a domain this cookie. It's set based on whatever you're setting it from. So as a server receiving a cookie with host on it, you know that it hasn't come from a subdomain that shouldn't be setting it for that host. And of course, and the path must also be the root. And we do in fact have a finding for this at DBG: session cookie with missing or misconfigured prefix. And one thing to keep in mind is that a lot of cookie issues and vulnerabilities in applications occur as a result of a lack of coordination or full maybe interoperability between how the browser behaves and how the server behaves. And so this is an interesting example from a Portswigger researcher, and it's quite simple, really. The way it works is a cookie is set with some white space, I believe, prefixed ahead of the cookie. And so because of this, even though they're using the host prefix, there's white space that precedes that, and the browser doesn't recognize it as a host only cookie. And as a result, the browser lets the attacker, in this case, set a domain. So you can do a cookie tossing attack here, and when the server reads it, so in this case it was specific frameworks, they applied a normalization where they strip the white space. So if you strip the white space, then they recognize that cookie as a host secured cookie, which means that they can't tell that it was set by a subdomain. The assumption was that it wasn't. So it's kind of a bypass for this mechanism that existed because of what you might consider a vulnerability. Oftentimes in these situations, it's hard to know who to blame, right? Do you blame the browser vendors or do you blame the server? Ultimately, it's an interoperability issue. There is not a shared standard for how these things are parsed. And a lot of issues like this arise across web security. And yeah, many of them can be hard to fix, and many of them you'll see arguments about, because a lot of times, and I'm not saying that this is the case here, but a lot of times you have certain groups, again, server, framework, developers, maintainers versus browser vendors, maintainers, who point the finger at each other. Cookie storage and lifetime is worth commenting on because these are also attributes that I didn't mention already. From a security perspective, they're generally less interesting. There may be some times where they play an important role depending on the type of application you're looking at. They're quite straightforward, really. If you set either a max age or an expires, attribute, you're effectively setting a lifetime for the cookie. You're telling the browser, hey, this is how long you should store this for, either by setting a date or by setting like an amount of time in seconds. The browser doesn't necessarily need to remove them after that time, and you'll see that this often is the case with certain browsers in certain situations, so it's not a perfectly reliable mechanism. Now, when either the expires or the max age is set, the traditional way to refer to these cookies is persistent. The reason being, when neither of them are set, the cookie should be, in theory, removed by the browser, and this would be called, I say historically, a session cookie, because that terminology has kind of evolved to rely on or to denote something different. So this context of session cookie versus persistent cookie is very specific in the framework of cookie lifetime, and you typically don't hear people referring to cookies in that way. Usually if someone says session cookie, they mean a cookie that is designated with managing a user's authenticated session and tracking their activity on an application. They don't mean a cookie that's going to be removed when a browser is closed. Also, a behavior that might not strictly be followed by browsers. So also worth keeping in mind. Hence the reason why I think, in part, these mechanisms are not so important to focus on from a security perspective outside of certain rare situations. Another thing relating to the storage that's worth mentioning, just because historically some attacks have arisen because of these mechanisms. Mechanisms is maybe not the right term to use. Maybe I should just say the reality of the situation. The reality is, whenever you're dealing with data, you don't have unlimited storage. You're going to have data that gets capped at certain sizes for practical reasons, and that includes cookie size. It includes the number of cookies that can be set for a domain. It includes the total number of cookies that a browser can actually store on a system. These are approximate sizes. They vary browser to browser and surely will vary over time as well. They maybe even can be configurable. Probably you'd have to go into the developer settings for a browser in order to, or like the configuration settings in order to change those. But there have been a number of attacks over time that abuse these. And certainly another one of the areas in particular where those can occur is where you have, again, broadly what I refer to as interoperability issues. You have the browser that has certain limits, but you might also have web applications and server technologies and proxies, like reverse proxies, that have their own limits. Web application firewall is another great example. Like, all of these systems may be dealing with data in their own way and have their own limitations. And there have been many ways over time, many vulnerabilities that have been reported where people have been able to abuse these for different purposes. A very useful resource, if you're not familiar with it, is Can I Use, which lets you look up different features that are implemented in browsers, and it will tell you which versions of which browsers support those features. Sometimes I've been in there to try to find very specific behaviors. It doesn't always have everything very specific. Sometimes you have to search through, very kind of archaic forums and documentation to find certain things. But for the most part, it's a really great resource for a lot of browser features and understanding the differences between them. It won't keep track of, it doesn't keep track of different quirks in behaviors around things like, cookie parsing and cookie storage, as an example, or at least I don't think it does. So those things you have to find, you have to source elsewhere. And oftentimes, one of the best ways to figure out, how a browser behaves under a certain condition is honestly just to test it, just to create these circumstances of that condition and and see the behavior for yourself. All right. So same site attribute. This one I left to be discussed on its own because it's a little bit more complicated. In addition to standard cookie scope, the same site attribute was implemented in order to apply further restrictions, largely to protect against cross-site request forgery attacks. Because again, cookies, they're very permissive in where browsers will send them. And as a result, this has historically been abused to conduct cross-site request forgery attacks. You have an attacker that controls some functionality, maybe an entire site, and you cause the user's browser to make a request to a different site, and that request results in some action. and it results in an authenticated action on behalf of the user if the user's cookie is automatically sent by the browser. Traditionally, the browser, or historically, I should say, the browser looks at the target site, it looks at the scope of the cookie, and it's like, do these match? And then if so, yes, send it every time. Always be sending cookies. And that was one of the worst ways, it turns out, to actually implement that mechanism. It led to all kinds of vulnerabilities, so much so that now not only was the same site attribute implemented, but it also has a default value that is different from how browsers used to behave that is set across browsers. So let's talk about the 3 values of this attribute: none, lax, and strict. None is defaulting to how cookies used to behave, which is very permissive. So this would be considered the most dangerous setting and is pretty much never a good idea in situations where you have some type of session that is authenticated or has some other value. Lax is in general now the default that is set by browsers, and we'll talk about browser-specific variations in a moment. In this case, it is a little bit confusing. Cookies are sent in a couple of situations. One is where requests are same site. So what does that mean? If you initiate a request from one site and your target is another site that follows that belongs to the same site, right? Think site and origin, then that request will succeed. Well, even that is a little bit problematic because, as we know, site is more permissive than origin. Same site requests can be cross-origin. So if you have a vulnerability that lets you send arbitrary requests on some subdomain of another site, well, you can probably send requests to some other target site belonging to the same site, like a different subdomain or the root domain, and the cookies will be included because it's the same site request, even though the applications are different. And there's also another situation in which requests will be sent even when the request is cross-site, and that is when 2 conditions are true. One is that the request is a top-level navigation, so these are situations like user clicking a link or navigating to a URL. And the second requirement is that a safe method is used. So that would be a GET request, a head request, or an options request. Now, the problem with this is that safe and read-only means these requests should have no state-changing impact on the server. But we see day to day there are all kinds of applications that developers build that don't really follow these guidelines and do not adhere to keeping GET, head, and options requests safe. Any application where you can initiate a GET request, send parameters, and it causes some change, it updates a value, whatever, that is not adhering to the safe or read-only principle, and therefore that is a risky situation even when same site is set to lax. Finally, we have same site set to strict. In this case, cookies are not sent cross-site. So the same risk applies with applications that share a site but are distinct, but we remove those additional ways in which attackers might maneuver to abuse other quirks. Cookies are only included in requests when you're making a request from one site to another site, and those sites belong to the same site. I hope that's not too confusing. We do have, of course, at DBG a finding for when this attribute is not securely set, and that is session cookie without cross-site restriction. Okay. So browser behavior is also worth speaking about. So traditionally, browsers would behave by having their default be equivalent to same site none. That is how the web used to work, and as a result, cross-site request forgery as well as some other attacks were pervasive unless you implemented very specific and honestly kind of annoying and complex protection mechanisms against those. Now, Firefox sets same site to lax by default. Chrome, in Chromium-based browsers, and there is some variation across different Chromium-based browsers, but largely they implement this set of rules, which is a little bit confusing and I think can still be abused. As far as I know, they still haven't shifted away from this, but they do intend to eventually. Right now, we're kind of in a grace period where there are 2 relaxations to the default setting of same-site lax. So it does set same-site lax, but one, only after 2 minutes from when the cookie is set. So there is a time window to exploit a vulnerable application that otherwise would be made secure by this same site configuration. And the second exception or relaxation of same site lax is that cookies will also be sent with non-idempotent, I never remember how to pronounce that, but they can be sent with request methods that intend to or traditionally change the state in an application. So top-level post requests that are cross-site, known as lax plus post, can be sent seemingly in Chrome still. It's always worth, if you're on an engagement and you're trying to evaluate the risk of something, some deficiency, it's always worth double checking in that specific scenario. Even if this rule continues to hold true, if they don't move away from this, there might be other strange conditions that make a practical attack of what you're trying to do difficult or block it in some way. So it's always a good idea to evaluate a proof of concept, see how it works in your environment against your target application. And finally, Safari was worth mentioning, I think mostly because it actually has a much higher market share than Firefox, so I feel like I have to include it if I'm including Firefox. It doesn't set lax by default, but it does have third-party cookie blocking, which I think is strict enough that it blocks a lot of scenarios. But to be honest with you, I'm not super familiar with Safari. I haven't experimented with it too much. Probably I should. Common cookie abuse. So let's talk about some traditional attacks that have at least been given names that abuse roughly how cookies work. One is a cookie overflow, which is where you force cookies to evict you force browsers rather to evict important cookies by setting malicious cookies. So if you control a subdomain and you set a lot of cookies against a browser, you might cause it to purge other browsers because of it, other cookies because of its limited storage. A cookie bomb is a similar attack that abuses sending a large amount of data. This one sometimes can target servers. I think you could also target clients with this. It's using JavaScript to set very large cookie values. I think it's typically more of a denial of service type attack, but you might be able to find examples where it's used as an element or component of a greater attack chain. Sometimes there are certain denial of service conditions that can help further other exploit vectors. Cookie tossing, we already talked about this. This is a situation where you're able to assign cookies within a subdomain or some other context where you can broaden the scope of that cookie to affect something that you couldn't normally set a cookie from directly. And finally, session fixation. It's not really a cookie-specific issue necessarily, but it probably hits cookies the worst. And this is a situation where if you have a cookie-based session management system and you have some way for an attacker to either set or to know cookie values from a starting point, and that user authenticates with an existing cookie, and the cookie value that is used as a session identifier is not regenerated but is accepted by the application and reused, that is known as session fixation. And it can lead to session hijacking in the worst case scenarios. And of course, we have a finding for that, session fixation potential. I mentioned a few times CSRF, and there's more I could cover in the relationship between CSRF and cookies, but ultimately I think it deserves its own session where we cover all of the intricacies of CSRF, especially on the modern web. So coming soon. And I did think it was important to cover OWASP ASVS, Application Security Verification Standard, version 5, Chapter 3, Web Front-End Security, 3.3, Cookie Setup. These are the ASVS requirements that apply to cookies. I'll just go through them. 3.3.1, set secure and ensure the secure prefix is set if host is not implemented. 3.3.2, ensure that same site scope is restricted. I'm obviously simplifying these from the full requirements. I think probably it goes on to say set it as restrictive as possible. 3.3.3, unless designated to be shared, set the host prefix for all cookies. 3.3.4, use HTTP only if possible. So this feels a little bit more like a recommendation if you go and read it, as it as it is written. It is a requirement within the ASVS, but there is some level of acceptance that HTTP only in practice has limited attack mitigating potential. And finally, 3.3.5, ensure cookies names and values are not too long. And that really, I think, applies in a few different circumstances, but it's always worth keeping in mind the situations where attackers can set cookie names and values that can lead to different types of abuse. Finally, security testing considerations. If you're testing systems that are using cookies, the first thing you need to ask is, what is the purpose of the cookie or cookies assigned by the application? How are they scoped? How are they protected? Under what situations is the browser going to send them? Are there multiple applications that share a site scope? Now, this is one that it definitely is worth keeping in mind from a penetration testing point of view, but I think often it will apply more from a bug bounty point of view, just because when bug bounty hunters are looking at scopes, they often have a much greater scope than you would for a pen test. Pen test, usually it's, here's one application, go find all the issues that exist within it. Bug bounty is like, here's the infrastructure of an organization, go see what you can do. And in that case, definitely, you're probably much, much more likely to be able to find a situation where you can abuse two different applications that share the same site scope in a way that lets you exploit how cookies work. Can browser differences and quirks be abused? Very important to keep in mind, especially if you're trying to build a proof of concept. You obviously want to be using the browser that is kind of the most lenient for you, not the most secure, because you want to prove that it works at least in some situation. And final thing worth noting, are cookies handled in an unconventional way? I've seen a lot of applications that use cookies in unique and interesting ways that have weird behaviors and mechanisms. There are things sometimes that you can inject into cookie values. Sometimes the client-side application is reading and using cookies in weird ways. The really interesting vulnerabilities, I think, arise where you have interesting functionality that is dealing with cookies. And so, as with the first point, you always want to understand what the application is doing, how you can manipulate cookies, how the browsers send them, and I think that will ultimately let you come up with the most interesting vulnerabilities as they apply to cookies. And that's it for this session.